All right, these problems are the most difficult math we've dealt with yet. So there's a lot going on here. There's a few formulas we're working with. There's some either giant numbers or tiny numbers that we're working with. And so we're balancing all that as we work through this problem. Now, this specific one incorporates a couple big concepts we've learned about. One is the energy of light, and one is this idea of a mole. So some of the other problems just say, what is the energy of a single photon? If you're dealing with a single photon, it should be a tiny, 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 tiny number. So again, this is our gut check. Here we're dealing with what is the energy of a mole of photons. So one photon is a tiny number, but when you have 6.02 times 10 to the 23rd photons, that should be a decently large number. So that's what we're going to see in this one. We're going to go through use our formula. Again, those formulas are always available on the equation sheet. It's a good thing to have as a reference. It's also got the periodic table on it. But we need to multiply that number by a mole at the end to get our final answer. But if it asks for a single photon, you will not do that last step. So let's take on what we're doing. So we've gotten a couple formulas. Speed of light equals frequency times wavelength, which we could rearrange that several different ways. But in this one, we're solving for energy. So we're going to use energy equals Planck's constant times the speed of light divided by wavelength. Now let's take a minute and look at units. So just units, we're going to go joules times seconds. And we're going to go meters per second. And then we have our wavelength. So if we cancel, the seconds will cancel. We want to solve for joules. And so down here, we need wavelength to be in meters to cancel. Notice right now it is in nanometers. So our first thing is going to be a conversion. Now we've worked on this with dimensional analysis, right? So I'm going to start with 701 nanometers. And the reason we put it in that format is because that gives us an idea. Visible light is around that spectrum, so it gives us an idea of, is this visible light or not? So we're going to multiply that. Nanometers are on top, so we need nanometers on the bottom, meters on top. 1 meter is equal to 1 times 10 to the 9th nanometers. Or you could say 1 nanometer is equal to 1 times 10 to the negative 9th meters. Either way, but you got to make sure, right? If we have a large amount of nanometers, it should be a tiny number of meters because a meter is big, nanometers are tiny. So put that in, 7 times 1. I'm going to use my EE to the 9 button. So I get 7.01 times 10 to the minus 7th meters. And again, for this, I wrote on my calculator, I wrote row 1 EE 9. For some people, that looks like times 10 to the blank as a button. That's a better button to use than trying to write all this out with the carets and things like that. So now I have my meters. So I'm going to plug in energy equals 6.626 times 10 to the minus 34 joules times seconds times our speed of light all divided by there we go. So we have a tiny number multiplied by a larger number divided by a tiny number. So let's see where we end up. A little bit harder to do. Got to check on this. 6.626. I'm going to use my EE button to the negative 34 times 3.00 EE to the 8th, and then divided by 7.01 EE to the minus 7th. Still get a tiny number, which is good. 8.4 times 10 to the minus 19th joules. Now, that is for one photon. This is the energy of a photon. Now I want the energy of a mole of photons. So that's going to be the energy of a photon times 1 mole of those, which is Avogadro's number. So we're going to say 2.84 times 10 to the minus 19 joules times 6.02 times 10 to the 23rd. 6.02, I'm going to use my EE to the 23rd, and I get 170707. So I'm going to call that 1.71 times 10 to the 5th joules. That's the energy. It asks for what is the energy of a mole. My unit may be, right, with how I solve joules per mole, because this is number per mole. But since it called out mole in the problem, then it's just looking for the energy unit, which is why we only have joules over here. So again, the joules of one photon, tiny, tiny, tiny number. The joules of a mole of photon is a big number. So let's plug that in, 1.71. There we go. Difficult math. Make sure you got the equation right, that you're solving for the right thing, that you don't have frequency in there when you need wavelength, but you can always interconvert frequency and wavelength using that first equation I showed. So a lot going on here, and then pay attention to the details. Is it asking for a single photon or for a mole of photons? Are you in nanometers when you should be in meters? So a lot of things to check on these problems.